Hello friends. So today's session we'll be going to discuss about complex powers in terms of symmetrical component. Complex power. So here if the symmetrical components of current and voltages are known, if you know the values of symmetrical components of currents and voltages, then power in a three-phase circuit can be calculated directly from the components. For example, if the total complex power flowing into a three-phase circuit is given by S equals to P plus JQ. Okay, so here if you know the value of components of current and voltage, then we can get the value of power in a three-phase circuit directly from the values of components. So here let us the total complex power flowing into a three-phase circuit is given as S equals to P plus JQ. So this we can write as VA into IA conjugate, VB into IB conjugate plus VC into IC conjugate. Here S is nothing but total complex power. Total complex power. Here P is nothing but active power and Q is nothing but reactive power, and also the star indicates conjugate. Star indicates conjugate. So now what I'm going to do here is I'll be writing this expression VA into IA conjugate plus VB into IB conjugate and VC into IC conjugate in terms of matrix. So I'll be going to write this in terms of matrix. So I can write here S equals to P plus JQ. So I'll write this in terms of matrix form, so that VA, VB, VC into IA conjugate, IB conjugate, conjugate, that is 1 cross 3 into 3 cross 1. So you can get 1 cross 1, that is the value of VA, VB, VC. So here you can write here in terms of matrix VA into IA conjugate plus VB into IB conjugate plus VC into IC conjugate. So once if you are writing this, give this as expression 1. Give this as equation number 1. So next what you are writing? So VA, VB, VC is nothing but the phase voltages. So here I am going to write phase voltages in terms of symmetrical components. Phase voltages in terms of symmetrical components. Before that, I am going to write this VA, VB, VC in terms of conjugate. I'll write the transpose. I'll write this in terms of transpose matrix. That is, I can get 3 cross 1 matrix VA, VB, VC transpose. Okay, so how we're getting this transpose? So now we can see we can get VA, VB, VC is nothing but I'll write in terms of transpose. So I am writing phase voltages in terms of symmetrical components. So this we had already done in a previous session. So just go for the YouTube videos to get this in my channel. Uh, so now here this is from a previous expression we had already done. Phase voltages in terms of symmetrical components we'll be writing in terms of matrix with a transpose. So give this. So next what I will do, I'll just rewrite this as VA naught, VA1, VA2. Just see here. So I'll write here VA naught, VA1, VA2 transpose, and transpose of this matrix I'll write. So if you're writing transpose of this matrix, we can get like this. So give this as equation number 2. Once if you're getting this, now we can apply the matrix rule. So A into B, matrix multiplication transpose is you can write as separate transpose of the matrices. Suppose if it is A and if it is B, A into B whole transpose, I can write as A transpose into B transpose. So next what I'll do, similarly I'll do it for the line currents in terms of for current, because power will be calculating once if you are getting voltage, next you have to calculate current. So the line current in terms of symmetrical components, again the same thing. Here the transpose conjugates will be having, so this conjugate, with the help of this matrix rule, A into B whole conjugate you can write as A conjugate into B conjugate, then you can get the conjugate values of, we can write it separately. So again here A conjugate is nothing but A square from the A operator. Similarly, A square conjugate you can write as A. Using this, wherever there is A square, there I'll write A, the conjugate values. Conjugate of 1 is 1, you can write. Conjugate of 1 is 1. Similarly, 1 is 1. Here 1 is 1 and A square is A and A is A square. Similarly, here 1 is 1. A is A square is A. I'll substitute the value of the conjugate values. So next what you can get, so that A, IA, IB, IC whole conjugate you can write as 1, 1, 1, 1 A square, 1 A square A into IA naught, IA1, IA2 conjugate. Here IA naught is a zero sequence current, positive sequence, and this is a negative sequence. Give this as equation number 3. Once you will be having the voltage and currents, that is multiply equation 2 and 3, you can get power. So that S equals to P plus JQ. So the active power P and Q is nothing but reactive power. So active power you can write here, P plus JQ you can write here as, this is a voltage and this is current that we are getting from equation 2 and 3. So again rewrite this. I'll just write in terms of matrix by removing the transpose. You can get VA naught, VA1, VA2. Similarly, by multiplying these, we can get 300,030,003. So here you can get a to the power 4, that we can write as 1. Okay, with the help of A operator, we can get 300,030,003 into I. So next what we are doing, I can write this as uh, 3 into VA naught into IA naught conjugate plus VA1 into IA1 conjugate plus VA2 into IA2 conjugate. This is complex power. Say it as complex power of symmetrical components. So this we can say it as apparent power as well. 3 into VA naught into IA naught conjugate plus VA1 into IA1 conjugate plus VA2 into IA2 conjugate. So that if the symmetrical components of current and voltage are known, then the power consumed by three-phase circuit can be computed from these components, that is from zero sequence and positive sequence, and from the negative sequence multiplied by 3 we can get the complex power values. So note this before solving the problem. So in terms of active and reactive power, the equations we can write, for the active power Vi cos phi, for 3 is a 3 into Va naught Ia naught into cos phi naught for zero sequence component plus Va1 Ia1 cos phi theta 1 for positive sequence plus Va2 Ia2 cos theta 2 for negative sequence, and the unit of real power is watt. Similarly for the reactive power, 3 into Va naught Ia naught sin theta naught for zero sequence plus positive sequence plus negative sequence in terms of VR. So the second point should note down before solving the problems. If VB is the base voltage, if VB is the base voltage and IB is the base current of the system, then complex power in per unit is given as, S is nothing but complex power per unit is given by 3 into the bracket Va naught Ia naught conjugate plus Va1 I1 conjugate plus Va2 Ia2 conjugate divided by base power, that is nothing but VB into IB, that is nothing but base power of complex, that is complex base power. So that power unit can given by actual value is S, actual value divided by base value is nothing but VB into IB. Similarly, if the symmetrical components of voltage and currents are given in per int directly, then if they are directly given the per int value, then you can use this one for total three-phase power. VA naught into IA naught conjugate plus VA1 IA1 conjugate plus VA2 IA2 conjugate. So remember these points before solving the problems on complex power. Thank you.